Good morning, everybody. This webinar is going to start in 3 minutes. See you soon. Hello and good morning, everybody. Welcome to the fourth webinar of the CLT Toolbox webinar series. Today, we're going to be covering a really interesting topic, which has had a lot of interest, the structural fire design of timber buildings. So I'm Adam, I'm the CEO of CLT Toolbox, also a structural engineer. And today we've got presenting with us Marko Dimitrijevic. Sorry, Marko, if I still struggle with the surname a little bit, but product manager. I'm doing the presentation today. So I'll be doing the working as the MC today. So I'll be covering an introduction, a bit of housekeeping, a bit of information about our latest releases before passing it over to Marko. So before we do that, we've got a lovely photo of our software team in Indonesia at the end of Ramadan, which we always like to share some great photos of our team. So for those joining us today, there's a few different ways you can interact. Firstly, we recommend anyone to jump into the chat. Feel free to introduce yourself and say hello. Feel free to have commentary as the webinar goes. We do have some real timber experts on the attendee list today, so we encourage you to sharing what you think about some of the topics as we go ahead. Secondly, you can ask questions in this question mark icon here, and then we're going to actually get to your questions at the very end of the webinar. So before we get into that, we'd like to just touch on a couple of our most recent releases on the software. So on CLT Toolbox, currently we build engineering software calculators that makes mass timber easy to design with. In April, we had a really exciting release on the GLT compression perpendicular to grain, also CLT compression perp to grain, integrated both with screw reinforcement from our partners, including Eurotech, Siga, Spax, and Rothelblas, and also design checks to current and new Eurocode, and also better visual feedback when you're doing the design. And most recently, well, today actually, we've been working really hard to get this release out. We've been really excited by it. And this is our a major fire design release, which has been about 15 months in the making. So this is both the CLT and GLT with multi-layered fire design options, enhanced support for exposed or protected options, the Austrian National Annex, the new draft Eurocode, analytical methods, supply-specific charring integration, and also better user experience as a feature on the loading calculators, which we're about to share with you today. So we can't go without any webinars of thanking our partners who've actually partnered with us. So one of the things that we offer on the platform is the ability to select real supply chain available products, and we work with the partners to manage their grades and actually what's available. So thank you for our partners. We wouldn't exist without you. And we've got a lot more about to come soon based on recent signings. All right, before I pass it on to Marko, so there are challenges to the timber option, and in it, whenever you got challenges and different steps. So for example, you got one of the challenges of managing grades and availability of the supply chain. You've got the current Eurocode shifting over to the new Eurocode, and you've got the maintenance of existing design tools. So whenever there's things like that, there might be things that take time and money. What we exist to do is to build calculators and make it as easy as possible for the design automation to actually have a profitable design of timber buildings. So that's what we have on our platform. It's calculators, both on the member side of things, so glulam, LVL, CLT, but also connections as well. And you can design all of that on our platform. So with that said, we're now going to get into the interesting topic today of structural fire design of timber buildings. So love to pass it over to you, Marko, and I'll see everyone at the end of this webinar.
Thanks, Adam. So I'll just quickly share my screen. So, hi everyone. Thanks, Adam, for passing it over. Welcome to the fourth episode to the CLT Toolbox webinar series. For those attending our webinar for the first time, I'm Marko, product manager at CLT Toolbox, and I'll take you through the structural fire design of timber buildings. So at the beginning, let's take a look at what we're going to talk about. So we are going to start with the challenges in timber buildings, then look at the chemical reaction of timber and fire, then go to the regulatory control of fire safety in timber buildings, and after that, we'll take a deep dive into the structural fire design theory and check how you can use CLT Toolbox for structural fire design in post and beam office building example. So at the beginning, let's kick off with challenges in timber and fire. In the last decade, there has been a lot of increase in timber as both for structural and architectural material. Aesthetics, sustainability, fast prefabrication, and seismic performance, they are just some of the things that make timber highly attractive. Yet, despite all of these advantages, there's a number of issues being raised about the use of timber as a structural material. There's a lot of concerns for durability, acoustic performance, and especially fire safety in timber buildings. Many investors, developers, architects, and engineers remain skeptical about timber's fire performance. So this is especially true when fire regulation and codes have not fully caught up with the capabilities of modern engineering timber products, especially for CLT and GLT. Of course, there is a lot of concerns because of the timber's combustible nature, and there's still a lot of questions around charring, flame spread, fire resistance, and fire separation. It's good to first discuss what are the important considerations that we're going to talk about today, because there is a bigger picture involved in just structural fire design. So there is a question about exposed timber and how much we can have it. And that's pretty much the story for every timber project, and how different services interact with each other and how the fuel is added. There is another open question for traveling fire for open offices, then for life safety, firefighting intervention, especially as buildings are getting higher and higher. Then what's about reliable encapsulation and connections? What about continuing the decay after the FRL has been achieved? There is the idea that the standard fire tests are basics of testing, but parametric testing represents real fires. Also glue line failure, and which may lead to secondary flashover. Then, of course, there is a lot of question about self-extinguishment, and of course the sprinkle reliability. So sprinkles are being very effective fire protection measure that can eliminate a lot of fires in very start. And at the end, we have a question about compartmentalization strategies. We can also bring here a list of some of the excellent resources are there to cover that are great to covering bigger picture of fire design. RISE has done incredible research. Of course, Andy Buchanan and world-leading group of fire experts have created a great, really great fire design guide. And there is a different industry association like Swedish Wood, which created a great guidebook, which also includes some references and instructions for the fire design. I would love to start our presentation by explaining that the green tick and CLT toolbox cover polisher scope, and you always need to consult and collaborate with fire engineer to get to know the full picture of fire design. So to get going, we'll start with structural fire design and chemical reaction between timber and fire. At the beginning, I think it's good to take a look at what's happening with timber and fire. When timber exposed to fire, it undergoes a thermal decomposition through a sequence of physical and chemical change. These processes, so drying, pyrolysis, combustion, and char formation, are influenced by temperature, oxygen availability, and specific composition of the wood. So the way actually the fire works is if we get up to heat of temperature of around 100 degrees, the wood dries up, and for moisture, for some of moisture lives out in that moment, from 150 to 270 degrees, and sometimes this is stated as 300 degrees, the decomposition and formation of charring begins, and then the self-contained heat reaction occurs. So fire is a chain reaction between oxygen, fuel, and heat. Requires all three to be available. In most buildings, there is an adequate oxygen, and its availability of fuel, which dictates the initial growth of fire, actually. And pyrolysis is the primary mechanism, so heat breaks up down wood into combustible gases and char. Now we're coming to the part where we're going to look at how regulatory control for fire safety is built around timber buildings. So across the world, building regulation and codes define the minimum level of safety that every building must achieve to protect life, property, and emergency services. These rules are particularly important for combustible materials like timber. Also, it's important to mention that the rise of engineering timber products, and especially like CLT and GLT, has pushed the boundaries of building design, especially for larger and taller structures. And as timber buildings are growing in scale for complexity, so do challenges of proving compliance with existing fire codes and standards. And there is also a problem with the different fire regulation across Europe, where some countries allow higher timber buildings, while others are more conservative with limiting height or exposed timber. Part 2 of Eurocodes addresses the performance in structures in fire. And while harmonized across Europe, each country allows to adjust certain parameters through national parameters and nationally determined parameters. Eurocode allows the calculation of load-bearing capacity of elements based on the semi-probabilistic design concept with partial safety coefficients. An engineer can design element in the case of fire based on simplified calculation methods, and for example, to optimize the design of fire protection. So here's just an overview of existing codes. Traditional fire design standards focus on solid timber and glulam. That is part of the current Eurocode 5 for addressing fire. but there is a limited provision for CLT, or in particular for the basis of Eurocode, there is non-provision for CLT and its unique fire behavior. So then we come to Austrian National Annex from 2011, where the CLT guidance are added, but with some limitations that are still there. And we recently have introduced the draft version of the second generation of Eurocodes that introduces a CLT fire design framework, bridging critical gaps in early standards and aligning fire modeling with real-world performance. For designing timber buildings, fire safety is crucial for ensuring that the structure withstands a fire long enough for people to evacuate safely and for fire crews to respond. It's essential to prevent structural collapse and contain fire after flashovers, which is determined through a standard fire test or by equivalent calculations. So fire performance is evaluated through these three criteria. So we have adequacy. Does the structural steel remain standing after time, or it's preventing collapse actually? So we have integrity. Is the element still preventing passage of fire or hot gases, which prevents spread of fire and smoke? And we have the insulation. So is the temperature on the non-fire side of the element below 140 degrees? Together, these criteria are often called FILL, or fire resistance level, and we measure each part in minutes. So a structural wall may be rated with 90, meaning resists collapse, fire spread, and heat for 90 minutes. Column obviously doesn't need to maintain safe passage of fire because it's like one-dimensional element. But on the other hand, a structural wall needs to achieve all three. So column would have a different requirement for comparing to the structural wall. At the same time, if we look at the door is not carrying any structural load, but again needs to have a thermal protection and also allowing a safe passage in case of fire. So different building elements have different criteria with different building types. So then we can jump to structural fire design theory. And if we look closely at the beginning, the structure design and the different codes, there are different standards. So firstly, we can look combination rules for actions according to Eurocode. So actions in the event of fire are according to Eurocode 0 and Eurocode 1.2, reflecting to these chapters. So the combination factors psi are determined by different load categories of structural elements, and they are usually ranged between 0 and 0.7. The choice of combination factors must be considered if structural elements' maximum load can be expected to occur in fire situations. A simplified method is there to verify the structural load bearing capacity in fire load, and in fire based on the reduced load. So we have ED. It's design load. That's design load effect when designing for normal temperature, and we have a reduction factor for design load in case of fire. The current Eurocode recommends two following methods for the design. So we have reduced cross-section method and reduced properties method. And compared to the new draft Eurocode, where we have effective cross-section method, which is equivalent to reduced in the current Eurocode, and separating function method. In CLT Toolbox, we followed design methods for load-bearing capacity following the general principles for reduced cross-section or the effective cross-section method in the new Eurocode, where the original cross-section is reduced by effective charring depth. So going into more details, the current Eurocode defines strength and stiffness D as 20% quantile values, and the conversion is carried out using the factor KFI. Eurocode 5 also defines this factor for different materials. So for instance, for cross-laminated timber, a value of 115 is taken from Austrian National Annex because it's not stated in the current Eurocode. New draft Eurocode 5 replaces the 20% with a factor K theta, the temperature depending factor, reduction factor for strength or stiffness property, and together they're using in this equation with the same KFI factor, which is in this case defined for different type of categories. So we have 125 defined for structural timber, finger joints, solid timber, glue solid timber, also 115 for both glue laminated timber, block glue, lam, and CLT, 150 for wood-based panels, and 110 for LVL. From a current Eurocode 5 point of view, here is the reduced cross-section method. So first we have a reduced section. We calculate engineering properties based on effective section, and we do analysis and design with the load combination and verification for the fire case. So if we jump to the Austrian National Annex, which is probably one of the advanced in context of the timber design and CLT, although is based on the current generation of Eurocodes, it provides introduction to CLT and CLT fire design, and because of that, it's widely accepted by designers across Europe. It focuses on passive fire protection using simplified methods and nominal fire exposure. So here are some of the preview of the properties, and here are just explanation and high level on the second generation and the draft Eurocode. So compared to the current Eurocode and also the Austrian National Annex, this version introduced CLT-specific fire design framework and chapters, bringing critical gaps in that were existing in earlier standards, and also improving fire modeling. So here are just some of the improvements, including connection in fire. So there we have exponential reduction method for screws. Also, what's happening with connection details exposed with fire. There is a detailed information about insulation and integrity analytical methods, separating function method, also analytical approaches for insulation and protection, combining with the multi-layered approach, which we're going to talk about shortly in detail. And this helps solve multidisciplinary problems much faster. There is increase of material scope. So as I mentioned, CLT is now included with the dedicated section. Also, the parametric fire crews are included with the new models, which are available in this code. So now we can zoom into the draft Eurocode and talk about what is actually the multi-layered approach. So if we look at the CLT panel, we have individual lamellas going into the longitudinal direction or zero direction, and there is a glue which separates lamellas into longitudinal and transverse or 90 direction, and so on. So because of this, the actual fire behaves differently relative to the timber and relative to the glue line. At the start, from 0 minutes to TCH, that's the time of protection that a pyrolysis reaction hasn't even started. That's because we have some protection layers, so plasterboard, gypsum board, for example, when we have a protection of X minutes of no charring. Following that, we have a period where charring begins, but even through a plasterboard or the protection system is still there. So if we remember the chemical reaction at the 300 degrees, charring starts. So even the protection layer is still there. That represents phase 2. So we have a reduced char rate. It's going very slow, and then the protection falls off at some point. And whenever something falls off in timber, there's actually much faster char rate for some amount of time, and that represents the phase 3. And that's increased char rate is happening for some amount of period of time, and after that, the charring layer actually has an installation effect, which reduces back to the normal char rate again. That point is at 25 millimeters, and it takes like that up to the glue line point. The next phase depends on the type of glue used between the lamellas. So the new Eurocode introduced a much stricter validation and testing to ensure glue line maintains structural integrity under fire. And you can check out more details about this in Annex B of the new draft version. On the other hand, in Austrian National Annex, there is a classification of MUF adhesives where there be no elimination, and PUR adhesives where the elimination will occur. In that case, charring rate will speed up again significantly. Considering multi-layer approach and new Eurocode, there's a lot of new factors that are introduced. I'll take you through some of the important points and factors, but we'll also look into all of these factors in the app actually in the next couple of minutes. So first, we can have observation of a gap factor that takes into account the gaps that occur on site or in production. So whether this is because of the tolerances or production limits, we have to take into account what gaps are occurring on our systems. So for gaps more than 2 millimeters, that will have an impact on the char rate. So you can see that the factor for gap is from more than 2 millimeters or more than 5 millimeters with 2 directional charring is 1.2, which can significantly impact our char. So going further, we have a factor of K2 with the notional charring rate in the second phase. There's a difference based on the protection time. So what is a plasterboard, fireboard, mineral wool insulation, and based on all of these, we can have different phase 2 protection time. So it really depends on the type of protection factor. There's also a factor K3, which determines phase 3 notional char, and phase 4, which is a consolidation phase. So all of this will also point out in our calculation in the app. Now we can take a look of zero strain layer. So what this means is that once we have an actual char layer, there is actually heat impacted layer which loses some of the structural integrity and treated differently. So it's defined as a heat effective timber zone just beneath the char layer, although it's not charred, so it can just no longer carry a structural load due to thermal degradation. And it marks the transition zone between the charred out layer and the intact bearing core or intact timber. So considering this, current Eurocode has a fixed value of 7 millimeters for a zero strain layer. Austrian National Annex used more conservative approach of 10 millimeters, while the new Eurocode is calculated based on several factors. So based on time, location, lamellar orientation, and fire spread. And what is more important, it considers even more into more detail. So it compares tension with compression side, first versus internal layer, longitudinal versus cross layer, and protected versus unprotected faces. So a lot of this is being considered for calculating zero strain layer. This is just a preview of how this looks in our app. So we try to maintain our exposure of formulas and how things are being calculated. And we have a special focus on fire design. So this is just a preview of calculation of multi-layered approach and zero strain layer. So this is something that I'll also point out in the app with our example in the next couple of minutes. Also, what is something that is worth mentioning is the multi-layered approach, which provides protection from insulation, plasterboard, plywood, etc. It's an analytical method which enables dynamically to create a buildup, and there is a significant big outcome in solving the multidiscipline overlap between structural, fire, and acoustics. So we are now able, with the new Eurocode, to manually configure each the full build-up and see what is happening with our fire design. The effects of glue line failure is something that I already mentioned briefly, but as I mentioned, there's a detailed section of Annex B about testing and requirements with the new Eurocode. There's also ability to use the Austrian National Annex within the fire design calculators, and you can even compare how this can have an impact. But what is more important is that you have the ability for selecting this and manually configuring glue line integrity in each step, and for all the both CLT floors and wall calculations. Going into our design, so we have our example of fire design of post and beam office buildings. Here, if you haven't been to our previous webinars, you can check them out on this link. So we have webinar recordings with our community forum, where we explain preliminary analysis, lateral stability, and the detailed connection design for the same example. Now we're gonna use the same example to verify these members in case of fire. So for ones that you who are here for the first time, here's the example building of 6-story buildings that we used as an example. So the building location is Amsterdam, with the dimensions of 24 times 48 meters and story height of 4 meters. Floors are made from 2 times 6 meters, equal CLT slab spanning in X direction. Slabs are supported by glulam beams in the Y direction, and the supported GLT beams are simply supported with a span of 8 meters. We have also the glulam columns as well, and here is the recapitulation of what we designed in the previous webinar. So we have floors of CLT 180, 5 layers. We have beams, dimension, columns, dimension, and so on. We're going to start with a fire design of CLT beams. So here is the load analysis briefly. So we have CLT floors, we have concrete screed, acoustical underlayment. We have additional dead load of 1 kilonewton per square meter. We have Class B office with 3 kilonewton per square meter. We have also snow and wind loads. In the previous episodes, we showed how we determined CLT thickness. We calculated 185 layers from KLH panel, and we used the vibration, new Eurocode vibration method, which were governing factor in this designs with around 96% utilization. Now we're going to take the same panel, and we're going to check what is happening with the fire resistance of 90 minutes. We're going to use also the Dutch National Annex, and we'll check 2 options. So we'll have the exposed underside. So we're going to see how is this design working with no protection, or we'll also check the option 2 with which is protected from below. So we have 80 millimeters insulation and 2 times 15 millimeters plasterboard. So let's jump to the app. Here we can go to CLT floor. We can select CLT floor fire design, and here we have an option for selecting either existing project. So we can add to something that we already calculate, or we can create a new one. I'll create a new one, and I'll add to the scope for my team. So we'll have webinar 4 CLT floor fire. So recently we pushed the new updates together with the fire design. So we have a new UI for landing page, and also some improvements on the preview of the results on the side. So you can always see in the input area what's happening with utilization numbers, and also some improvements on the loading. So it's easier for getting around when designing. So here we can start with either configuring manually what are the CLT properties, or selecting some of the partners' products. So here, as noted, we can go with KLH. We can select 185 layers, and in this case, we'll see how this automatically being updated both on dynamic imagery but also on the result side. So concerning the fire method, we can select between Austrian National Annex, new Eurocode, or even standard fire test. So in this case, we'll stick to the new Eurocode method just to observe how this is affecting the design and how all the points we mentioned are included. So here also you can simultaneously see what are the changes between these methods. So At the beginning, we can start with inputting 90 minutes resisting time. Also, what is interesting, we can select the char rate. So this is something that can be either with manual input, CLT supplier, or calculated with Eurocode. So we can use the Eurocode calculation on this. Then we have option for selecting the glue line integrity. So as mentioned, this is based on the type of glues that are being used. So in this case, I can select this as no. But this is something that we are also going to look into the details in the next couple of minutes. For the size exposure, we can go with underside, and in the first example, we can go with no protection from below. So we have here option with adding protection, but if we select no, we'll see what is happening now. So we got a notification that the panel calculation failed because we need a minimum of 3 intact layers. So we see here how the fire is charring rate are developing, and what is the effective cross section. So we know that after 90 minutes we have burn of 95 minutes, and we have also, because of the cloth layer and the zero strength layer, we can see that we have practically only one layer here. Why that's the reason why it's failing. How we can impact this? So first we can talk about the glue line integrity. So if we go on the more information on the supplier, so if we click here, we can have information about the supplier and production, but also in terms of the technical information, we have here information about lamellas, information about edge gluing, but also glue line integrity and fire. So here it says that this could be possible on requests. So just changing that to yes is something that is possible with the supplier, and we can see how this in this case is impacting the design. In this case, we have burn of 70 millimeters after 90 minutes, also including almost 60 millimeters for zero strength layer. And in this case, we are possible to proceed with this design, and just in case of concerning the fire. I'll also go adding other properties for this example. So we have option for char factors. In this case, we have the gap factor. So we also I also mentioned in the beginning how this can be important for the design. So again, more information can be something that can be very helpful, how this can be understood properly, and also containing some of the references for the design. So this, if is less than 2 millimeters, will affect the design of factor for gap to 1, or if it's as mentioned bigger or 2, or we can say 3 millimeters, that will affect the design, and that's also something that will affect the design significantly. Concerning out of fire design, we can have option. We already have predefined Eurocode. We can add National Annex for our location. So we're going to select Dutch National Annex as in our example. I'm going to quickly input the loads that are according to example we had. So we have default load combination. We have category B for office areas, service classes, self-weight will be considered. I'll add topping. So we have 1 kilonewton per square meter for topping. Additional dead load, live load are 3 kilonewtons. And going further with the analysis, we have 2 span. I'll just type in 6 meters. And here we have option with different analytical methods for the stiffness calculation. So again, more information on this part can be helpful in terms of have a difference about the different application methods, but also what is in the background of the calculation and what are the limitations. And similar to that, we can have option for considering cloth layer. So in terms of the CLT production or for KLH, this is something I can set to yes, but again, in terms of the background of this, more information can be a bit helpful for understanding what's happening. design code for Eurocode. So here we have cases and KFI. So for CLT, as for both Austrian National Annex and Eurocode is 115. So I'll leave that as it is. Here we have a preview of results. So we have fire, shear, and bending. But here in these tabs, we have all the intermediate results, step-by-step calculation in detail. So starting with charring, we can see first what's happening with char factors. So these are the old factors we mentioned at the beginning. So K2, K factor for gaps, K3, and so on. So here we have the values of these factors based on the selected inputs in our scenario. Then we have basic char rate, notional char rate, zero strength layer calculation. So here is the practically all the consideration about zero strength rate and when which value will be adopted based on the new code. Then also, because we have double span, we'll also take a consideration about the tension and compression side. We have protection information about for each protections, but in this case, we are not considering any protection, so we'll skip that part. And here we have information for practically effective thickness of the panels for both tension and compression side accordingly. I'll just scroll up back to some of the inputs we have, and I'll try to show you what the other example with what we have with the protection side. So we notice that if we don't have protection in this case, our panel is failing. So we couldn't with this configuration with this gap, this thickness is just not enough. So we have option for either increasing the glue line, changing the type of glues, or reducing the gap. So in this case, we showed about that. The other option is, as I mentioned, just to use the other option and add additional protection to below the surface. So we'll use the underside protected. In that case, we'll have these drop-down menus, so we can manually configure different type of layers and protection. So as our example, I'll add three types of protection. So for the first one, I'll select mineral wool. And in our example, we have 80 millimeters of mineral wool. We have then 2 times 50 millimeters plasterboard. So that's already selected. We have tape type A, and we have 50 millimeters. So if we scroll up, we'll see how this is affected the design. So in this case, we can see how each protection layer affects the charring rates, in what moment charring has been started, what is the burnout after the 90 minutes. So we have the 31 minutes. So this is also with glue line integrity that is selected, considered as no. And we have a zero strain layer. So in total, we have reduction of 74 millimeters or effective 106 millimeters panel, which is totally fine for our design point of view. So that's also something that should be considered. If we go into details about the charring, we can see how now protection layer are being calculated in detail. So we have here about the basic charring rate, notional charring rate for protected phase, post-protected phase, and constellation phase. So this is with all 4 phases. Again, zero strain layer consideration, what's happening with the tension and compression side, so how this is differently affected. And then we have here information about the protection time. So depending on what we consider here, we have here underside of mineral wool providing protection of 24.7 minutes, gypsum plasterboard, first one and the second one. So based on that, we calculated what is the protection time. And again, we have here information both for tension and compression side of the panel, what is the effective rate. If we go into the details for other tabs, we have here effective calculation of stiffness for effective section. So for each layer, this is similar to the non-fire design, but just with a reduced section. We have information about the annexes. So in this case, for Dutch National Annex, concerning all the parameters for fire load, load analysis including both shear actions and bending moments according to appropriate load combination and coefficients. And we have design code, so both bending design and shear design according to each load combination appropriately, with information about utilization and also the shear, rolling shear. So that being said, I'll get back to our presentation quickly. So I'll also click save at the end and talk about some of the things we designed here. So based on the options of calculations, we have option with the acoustic protection. So we have 180 panel. We have also improved acoustics because we added layers, but the negative side of this design is reduced statics, and there's also need to additional consideration about the cost outcome of the panel difference compared to without protection. The second option is changing glues. So we noticed that in terms of our supplier, we are able to change the different glues which maintain the glue line integrity. That is within that we can maintain not just the panel but also aesthetics. Or the thing we don't know in this case is how this will increase the costing. So if we change the glue, that's definitely something that is going to be different for the case without initial glues. And the option 3 is just simply increasing the panel. So the aesthetics remain the same glue. So we're using the standard panels, but in this case, we're using additional timber. So in this case, this is probably the worst case scenario in terms of increasing the total build-up dimension. Before wrapping up, I'll also take you through the internal GLT column design, but again, in case of fire. So this is just a preview from previous webinars where we have loads from above that are acting on the ground floor column. So we have levels from above. We have reaction forces for all the loads, and we also have the beam reactions that are acting on this column. We have 400 by 400 GL24H Eurocode, again with Dutch National Annex, 90 minutes protection time, and we'll check first without and then with protection from all sides. And for protection, we're going to use 2 times 50 millimeters plasterboard protection. So if we jump back to the app, I'll start from the start. So here we can select timber column. We can select timber column fire. We can add to existing projects. So I'm just type in, it is the same project we have. So webinar 4 and GLT column fire. So we're going to wait a second for this to be loaded. So here we have GLT is selected for material. We can choose between suppliers, but we can also go with manual input. So here we're going to select GL24H. For a cross section, I'm going to type in 400 by 400 as we have in our example. First thing to note here, we're going to input the height of column. So we have 4 meters. We have no lateral restraint in both X and Y axis, so we're going to turn it off. You can also see the elevation of both axes in these tabs, so you can see what's happening with the loads, but also lateral restraint. Concerning the timber char data, so we have the 90 minutes with face exposed. I'm going to select both sides, and for initial design, I'm going to select to be all unprotected. This calculation for both GLT beams and columns are according to current Eurocode. So in this case, we're using the simplified approach from the current Eurocode. We have option for adding National Annex. I'm going to add Dutch National Annex in this case, as we have an example. For loads, we already have defined and selected that live. I'm going to just add wind and snow and look through the inputs we have. So we have category B for office areas, service classes, self-weight are considered, and now we have the actual force from above. So in this case, I'm going to input the forces from above. So we have 624 here, 576, 54.6, and for snow, something like this. So we have 0 eccentricity from above, and here we have option for connecting a beam loading. So this is something that we can add additionally. So also it's good option here to know that we can actually not just add loads, but also calculate the eccentricity. So we're going to select only left and right beam, and we'll input the reaction forces for both. So we have 76.7 here and 72 for live. Snow and wind are 0. The same we have in the right beam, so 0. For the eccentricity, so we know that the section is 400 by 400. The beams will be hanged on the side of the column, so it's a valid consideration that this will be more than 200. Maybe we can input 220 millimeters, just because we're going to have some kind of a connection part that will be distance from the actual surface of the column. So the same thing is safe to assume on the right side. Concerning load from lateral load, we don't have because any lateral loads, because this is internal column, but there is option also for adding. And the last part is concerning design code for Eurocode. So both relative coefficients on the cases, K-crit and compression, loaded edge for major axis. So I'll leave this on the compression. If we look on the output summary, we can see that our utilization and checks are all passing at 80%. So we are even good with this consideration without any protection. If we go into the charring part, now we can see here step-by-step process based on the current Eurocode, as I mentioned. So both inclusions of calculation about the charring rate, notional charring, the effective depth of this section is being calculated here. We can see also the charring rate and time in graph, and in the end, effective cross-section. So for the sake of example, I'll just also add some of the protection here so we can see how this is affecting. So just click this too fast. So here we can select top side is protected, underside, right, and left. And here we can select the product. So we can choose between these type of products. For the current Eurocode, we can have maximum of 2 layers with the same layers, but we can change the different thicknesses. So if we put here 2 times 15 millimeters plastron board, we can see what is the effective layer, what is the zero strength layer in this case. And scrolling back to the charring, we can now see how this is changing based on the protection layer. So we have differences in terms of the start of charring, and also the char rates are now applied according to what the protection we have. In this case, we have different effective layers. So we know that in our case, we don't need any protection, but just an example how in some cases you can include it. This is also something we can save, and also to bring it up that all the calculations you can have into PDF report easily. So to wrap this up, this is something we talk about today. So structural fire design critical for timber buildings, how timber behaves in fire, and how knowing some of these things can make fire design easily. Code compliance are evolving, and we at CLT Toolbox are trying to catch up that with the latest method. Also, really important thing is that fire engineering is a multidisciplinary field, and it's required collaboration between fire, structural fire, and acoustic design. And Toolbox helps simplify performance based on design. So that's about what we prepared now. We're really keen for any questions from and thoughts from what we presented here, and also looking forward for all of you who are interested in checking the app and see how this is performing with your design examples. Over to you, Adam.
Thank you very much, Marko, and that was a really great presentation. We had a really great turnout for today's presentation, so thanks to everyone who joined us. There has been some technical glitches on the viewing the Q&A, so someone screenshotted the Q&A. For some reason, it's disabled on my side. I'm not sure if it's not disabled for you, Marko, but in any case, we got a question here. Have you got a solution for the fire design of connections? Is this something that CLT Toolbox is also working on?
Yeah, thanks for that's a great question, and it's a really interesting topic because the behavior of connections fire is something challenging. So at the moment we addressed only the member design and the behavior of members in fire. Connection is definitely something we have on our roadmap, and as if you already have checked our connection design, that are really comprehensive and specialized for the mass timber context. But the fire design is something that will scale up and add it in some point as well.
Yep. Yeah, well said, Mark. And like you said at the very beginning, the exponential reduction method, it really enables good analytical methods to design connection details a bit easier. And yeah, so as we build out our software, those char modules will be integrated into our connection details. And on top of that, we'll be having the exponential reduction method with the screw suppliers. So thanks for that, Marko. So hi, Marko. I've got a project needing acoustic build-ups for walls for separating apartment rooms. Is this possible in CLT Toolbox?
Yeah, so that's also, thanks for that. That's also a great question. So in terms of the acoustic build-ups and the wall separating, so certain, as we show our protection options for both CLT walls and floors, you can type in not just the CLT material, but also full build-up layers. So for each layer, you can configure manually what is the sizes and the type of protection. And within that, you can check what is the full build-up behavior under test of fire. Just to point out, this is only from a structural point of view. So and on the element basis.
Yep. Great stuff, Marko. And whilst you're doing that, I might as well, I think we got time to just give a really quick version of the demo. So that does work in a similar way to Marko shared before. So with that, we've got currently on custom layout. But if you did say go to 90 minutes resistance, and similar to before with this, I think one of the interesting parts here is you can expose both faces. So you might have an internal load-bearing wall, for example, with a fire on both sides. If that's the case, you can add your protection layers to both sides, for example. So let's say if we've got on one side gypsum plasterboard, rock wool, and let's just make that 70 millimeters. You can see how you've got your protection on both sides occurring. In this case, we need a thicker layer to get it going. So we're still on, now we've got, well, 3 layers basically. So yeah, it does work in a very similar way. Just doing a quick version of the app, but yeah, showing that you can do fire protection on both sides. So I'll stop my sharing there. Good stuff. So I think there was, sorry for everyone on the Q&A side of things, it looks disabled for me, but I'm not sure if Ringo can message if there's any more coming through, but yeah, thank you so much, Marko. So I'll take the slide here and go through the final slides. So thank you, Marko. So that was a lot of that was on structural fire design, and we do have those in the app now. So we've got the new wall calculator and floor calculator with the Austrian National Annex, but also the draft new Eurocode. And anyone on this call, you can get access to the app for a full free pro trial. If you want to get your hands on using the software, get in touch with corey.jones@clttoolbox.com, and we'll do a 30-minute discovery call to see how and help onboard you onto the app. And with that, we'll give you technical support as well around the clock. So for the next webinar, we'll leave it there because we may or may not do this shear wall design there. But for those who have joined us today, thank you so much for your time. Really appreciate it. We're keen to learn from everyone. We had some really great attendees join today, some high-level fire experts. So feel free to share any thoughts you have about what we're building and the direction we're heading. And anyone in the education sector, we're happy to give our app access, because I think it's interesting to seeing the new analytical methods, how they're used compared to other analytical methods as well. So thank you so much. Great job, Marko, and everybody enjoy the rest of your day, and thanks for attending.
Thank you, everyone. Have a great day.
Bye-bye.